Greetings, this is this week's update. This week's update will be slightly different from the last week's. It'll be more of a demo than an update, okay? Let me just show you what we're looking at. We're looking at the live picture of the device. And we're looking at the serial port terminal of the device. Okay. As I switch the device on, the device starts to calibrate. As the device starts calibrating, it's running through the LEDs. Last week I showed what the LEDs were. A few more seconds. 24, 25, 27 LEDs. Okay. Our calibration is done. I'm going to put one marker, one marker down. I'm going to come up to the enter. And we can see that it's starting to read the markers. It's off the screen. It's now coming onto the screen. The markers are being read. Okay. And if I go up, we'll see the markers. Okay. The markers show lines. It's difficult to see it, but shall we say line number 9, start and finish. These are all lines. There are 20 lines from LED that transmits light to sensors that receive light. Those lines were shadows. The shadows define where the device is on the marker. At the moment now we have 23 lines. I'm going to add a second and a third marker. The second and the third marker, and I'm once again going to go and set it off again. One can see that it has begun to start reading the data, and it's going to start coming in from the bottom. From the bottom of the screen, you can see now that it's coming, starting to read. Okay. If I move up, I've now 46 lines which defines where these markers are. Okay. If I can let us just take one. Let's take the first one. The first one, let me do this with one marker. Recalibrate it. And I'll put in one marker. Okay. I'm putting the device in the middle of in the middle, opposite D7, D8. D7, D8 and D7, D8 on the top. and sensor sensor 3, roughly across sensor 3 and D5. Okay, D5 on the D5, D3 on the Y, and 7 on the X. Okay, that's basically where I've put the that's where I've put the marker. Okay, I come back and I start the measurement. Okay, let's move up. Okay, I said it. We up it in the Y in Y. We need to be roughly at 7. Okay. Seven, top. Okay. 354 changes. Okay. Okay. The top sensor is 7. Okay. Okay, 7. Okay. So if you go from 13 to 3, from 13 to 3, you go straight across the sensor. Okay, 13 to 3, straight across the sensor. Okay, from 13 on the top to 7 on the bottom. 13 on the top to 7 on the bottom is here. Slightly off, but it's slightly off. Okay. From 12 at the bottom to 4 on top. 12 at the bottom is here. 4 on top is here, straight through the sensor. Okay. And we go from bottom to top. We're looking at okay. Something happened here. I don't know what happened over there. From 3 to 12. Bottom lead 3 to top to top 12. Bottom 3 is here, and top 12 is here, straight across the sensor. Okay, let me take a look at why this one over here. Bottom change. Lead 15. Okay. This one over here is lead 15. Lead 15 is the last lead in the corner. If one looks at it, I'm actually covering it now. I'm covering that lead, so I don't take any measurements from that lead. Okay, that's why I didn't. That's why only one side. That's why only one line. Only one side showed up. Okay, but if one takes it here now, let's assume that we're bottom 3, 1, 2, 3, and to this far lead, it goes roughly along the. Okay, when you draw all these lines, okay, when you get all these lines, the lines show where the device is, where the marker is. Is there still what to do? Still what to do. Okay. This is the second version. The first version that I did it, I used 3D printed blocks. Okay, now these 3D printed blocks will soon become apparent why I have so many lines that I print. Okay. Okay, here's the blocks. 1 block, 2 block. Okay, I've recalibrated the system. Okay. We're going through. It's reading now the LEDs. Okay, and one can see that these two blocks that I've put in here have generated 284 lines to define the position of these two blocks. Okay, that's how I started. It's too much information for me at this point in time. That's why I've moved away from the blocks to smaller markers where there's less of a shadow, and it's easier to find the mark. It's easier for me to find the marker. If I have 280 lines, obviously I have a much more exacting position. But for this point in time, I want to use. Okay, I'm just going to turn off the lights. Okay. And I'm going to turn off the screen. Okay. And we are back in the dark. And I'm going to reset. And one can see that how the system works. You don't know why. You don't know why it didn't was unable to. What? Okay, that's the visible LED. Why is it not being able to see these? It's having it's sort of seeing that you can sort of see you can sort of see how it does the measurements, how it goes through. Okay. What we're going to do is I've now going to reset and calibrate in the dark. I'm resetting and calibrating in the dark. Okay. I'm now going to switch back on the lights. I'll switch back on the lights. Putting back the television, putting back the screen. Okay, the screen is switching on. Okay. And now I am going for a second time, and I'm seeing if going from switching on the lights to off the lights made a difference to the calibration. One can see that I can calibrate in almost total darkness, and I can calibrate. There's a way of doing this. Okay, actually no, I haven't done this. Okay. Okay. This is the screen. For the moment, I'm not too worried about it. Okay. Okay. So what have I demonstrated? I've demonstrated that I can measure XY position of markers. I haven't fully worked out the code to draw the lines and find the line intersects to be able to know how accurate it is or it isn't. But it is more than accurate enough for what I intend to do with it. Okay. Let me get live view, I've switched off. Okay. Where are we at? Okay. Okay. I can measure XY positions of markers. I can operate the warning lights. If one can see the warning, I've switched it off. The warning lights are the visible lights that start at the beginning. Okay. MQTT is something that needs to be still integrated in, and for Wi-Fi setup needs to be integrated in. Okay. There are some issues still with the way I've done this, and Rev 2 will more than likely be done a slightly different way. Okay, if one sees that at the moment now I'm having 100 counts dynamic range, 100, 200 counts dynamic range, sometimes even 400. But if I'm on full scale of 12-bit, which is 4096, my dynamic range, I can work a lot faster if I am well above the noise level, which at the moment now I'm not. I'm usable, but I'm at the not very far above the noise level, and I have to sample a few times to get valid readings. If the dynamic range was higher, it would be a lot easier for me. How does one get the dynamic range higher? At this point in time, I'm working with 18.5 milliamps in the driving the LEDs. Okay, IR LEDs is rated at 60 milliamps, so I can triple the current and probably more than triple my my measurement on the underside. More than tripling my measurement would mean that it would be a lot easier for me and a lot quicker to get valid measurements, instead of worrying about the noise floor. Okay. Worrying about the noise floor means I'm measuring a few times. I'm digitally filtering, which is acceptable, but I don't want to do that. Okay. As far as that's concerned, it would mean a redesign of the LED circuit to allow 60 milliamps instead of. Okay. As far as final costs concerned, I'm not 100% sure exactly where I'm planning on marketing this, at what price range. The problem with not knowing what price range means, do I go for added value or do I go for cheap? Blaring example of this is, do I go and put in a $6-7 lithium battery, 1.5 amp hour lithium battery, or do I tell the people, end user, go out and get AA batteries and put four AA batteries, put in 6 volts, four AA batteries in series, and Shalom Al Israel. 4 AA batteries just aren't rechargeable, and I'm talking about alkaline, not rechargeable 4 AA's, because I need 6 volts. It is a question. Do I add a way of uploading firmware via USB, or do I leave that out? Okay. As far as the other side of it is concerned, I have been working with my attitude of being as cheap as possible. As cheap as possible, I've been working with a $10 Orange Pi, $15 including shipping Orange Pi, to run Home Assistant and Node-RED. It is me trying to make this system as cheap as it would be possible for anyone to get it. I do not know how much it's going to be, but we will have to see. Okay. for now, I'm basically looking at going with ITED. ITED and Sonoffs as far as endpoints are concerned. At least for my advice, basically Sonoff Minis. Sonoff Mini is basically a $10 device. Okay. For people who live in the States, living in the States, we're going with the Shelly range of products. Shelly range of products. Okay. Why the Shelly range of products are over ITED? The Shelly range of products have got a UL approved. So if your house burns down, the insurance aren't going to come and say to you, used bad, cheap Chinese trash. Okay. If one goes here, Shelly 1 UL. Okay, slightly more expensive Wi-Fi operated switch, but however it is UL approved. Okay. You can buy four Shelly 1 switches for $80 for a smart home. Okay. This has been a little bit longer than my usual update. A bit more information. As one can see, I'm moving on.